So what we want to be able to show, okay, so when you build your circuit, you're going to have three types of gates. So you have a chip that actually has 4 separate XOR operations in a single chip. So it's a 14-pin chip that will plug into your proto board. Pin number 7, so the orientation is there's this semicircle and the left. So normally this is rotated, but fortunately this is going to match up with exactly how you're going to put this into your proto board. The bottom left, this one, which is normally the top left, this is pin number 1. This is logic gate number 1. So this is my XOR gate number 1 on my chip. So in the chart where it says XOR number 1, sort of in the middle of the chart, that's going to be these 3 pins. XOR gate number 2 is the next 3 pins. And then there's a ground. So the chip, in order to be able to do logic operation, needs a power supply. So you need to apply 5 volts to VCC and 0 volts to ground. So the printed circuit that you soldered together, that you power with with the 9 volt, well, not quite. The printed circuit that you, or the printed circuit board element that had surface mount components on it, that's powered with the 9-volt battery. There's something on that circuit called a regulator. The regulator converts from 9 volts, steps it down to 5 volts. The circuits, these chips, they're designed for TTL, transistor logic. Those operate, at least this generation of chip, operates at 5 volts. If you apply more than 6 volts, you'll fry these chips. So we have to, and if you apply less than 3 point something volts, they won't work. So we need a power supply that's between 3 point something volts and 6 volts, and AA batteries, there isn't a convenient solution to that. So our solution is 9-volt battery, 5-volt regulator, so we get a 5-volt supply coming out of our chip.